This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by iFixit, introducing the all-new ProTech Toolkit to give you the compact and complete toolkit for all things DIY. For $5 off your purchase of $10 or more, go to ifixit.com/twit and enter the code KNOWHOW at checkout. And by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code KNOWHOW in the billing section to get your $10 credit. Today on Know-How,
it's an Arduino Wonderland.
Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And for the next 30 to 45 minutes, we're going to show you some of the projects that we've been playing with so you can take them home and geek out on your own.
I feel like this is going to be an exceptionally geeky moment that we have.
It really is. Now, a few weeks ago, we did the Raspberry Pi Day.
Yes.
And there were a few people who tweeted and emailed and said, well, you know, you did the Pi, what about love for Arduino? We've been giving Arduino a lot of love.
What would the date be for Arduino, though?
Zero,
yeah,
one,
0, 1,
January,
1,
I don't know, first. But remember, these steampunk goggles, which we've got right here, this was an Arduino project. So if you've been wondering where all our coding stuff went, we've been doing it. And also, you remember we used an Arduino to program our ESCs. So haven't we been doing Arduinos as like the brains of some of the quadcopter builds? Yes, we have indeed. So we have been staying with Arduinos, but we're going to get a little heavier into it today. We don't want to give you any projects to do. We want to give you some learning. We do this every once in a while where we have you take the examples we give you and then figure out how to expand upon them. We do have some Arduino projects planned for the very near future that I think are going to knock your socks off, but for now, let's go ahead and do Arduino 101.
Yeah, we'll see about that, Padre. Let's start with the basics.
Let's start with the basics, and the basics actually come from a member of the audience who had a really good question that we can build a little segment off of. Hey, Bryan, what you got?
All right, so this one comes from Daniel Neighborhouse, and he asks, in reference for Know-How episode 191, can you spin up each motor through the Arduino Nano with the same software that you change the rotation? Trying to find another way to spin up the motors.
Now, in episode 191, what we had was we used the Blue Heli suite to program an Arduino Nano. In fact, this very Arduino Nano, if you go to the overhead, Alex, this is the one that we only soldered 3 pins.
That little baby guy.
That little baby guy, right. So what it did was it put the firmware on here to make this the bridge between the computer and the ESC,
right,
so that I could reverse rotation without having to resolder the wires.
And not just that, but also fine-tune your ESCs.
Precisely, yeah, reprogram it. But here's the thing, there's nothing that says I can only do that. Now the Blue Heli suite itself, the software, has no features that would allow you to spin the motors up and down. The flight controller did. If you remember a few weeks back on Project FPV 150,
right,
if you're using clean flight or base flight, you can jump into a little Chrome app that allows you to spin up all the motors or each one individually. But the issue with that is then it's already connected to the flight controller. So
right.
Yeah. We wanted to find a way if we could use the existing Arduino that we had for programming our ESCs to spin up each individual motor. And guess what, Bryan?
What's the answer?
It's actually really easy.
Oh.
Yeah.
Whew.
Yeah.
I was worried there for a second.
We've done this. Arduino speak PWM, which is the language of ESCs, just fine. Now you remember PWM deals with how the signal is pulsed. It's pulse width modulation,
right,
PWM. So for example, for every cycle, there's on and there's off. And the ratio of on to off determines what value you have. So if it's all off, it's 0. If it's just on for 1, you get 1,
right,
2, 3, 4, exactly,
5,
all the way
so
up to 255,
okay,
0 to 255.
Makes sense.
Makes sense. But what we can do is we can use the Arduino, either a Nano, or we're actually going to use a full size to sort of fake that signal, to make it up. It's not coming from an encoder, it's coming from the Arduino itself.
Well, that makes sense because it's just sending the signal, it's just interpreting and then passing it through, right?
Precisely. It's using a digital pin, and all it means is it turns it on for a little bit, then it turns it off. Turns it on and then turns it off. Let's show you how we are going to do it. And here's the fun part. I don't even have to write any code. I'm going to have to modify some in a little bit, but it is a standard example with the Arduino Sketch IDE, the Integrated Developer Environment. So everything that we're doing, you already have.
Nice.
Which we're gonna like. So here's what we got. I've got a little servo. This works on PWM, just like the ESCs. I want to be able to control the position of the servo by sending a signal to it via the Arduino. And in this case, I'm gonna use this Arduino Uno that I have mounted on my little breadboard prototyping.
Right, with a couple
setup.
of dials on there?
Precisely.
Nice.
So here's what we're gonna do. If you go to the overhead, what I need to do is this servo is gonna need power. So it means ground and voltage. And then it's also going to need signal. It needs the digital signal that's going to allow the PWM signal to tell the servo where it should be.
Right, which has been like all our other projects that we've done with the LEDs and things like that.
Precisely. And so what the servo is going to be listening to, and in fact what the ESC is going to be listening to, is how during a particular clock cycle, how much is it on and how much is it off. And then it's going to take that and it's going to turn it into a value for where the servo is pointing.
Very cool.
All right, so here's what we're going to do. I'm going to use jumpers. Here we go, little jumpers. So I need power. I'm going to take this orange one and put it into the center pin, which is my 5-volt voltage. I'm going to take this brown one and put it into the ground because I need to get ground out of it as well.
Right.
And I'm going to put this into one of the ground pins. And remember, when we did our Arduino projects, these are all labeled. So that's labeled G and D for ground. This one is 5 volts, so I'm going to put it into the 5-volt line.
They're right next to each other.
They are right next to each other. This one is the digital signal, so I'm going to take that. And I'm going to leave it for now because I don't know where I'm going to plug it in here.
Yeah, you have to set which, they're not ports, but...
Yeah, pins, right.
Pin,
so I
I
have to tell the Arduino what pin, what data pin is actually connected to the servo. This is easy because that's just power.
Right.
Power, you don't assign power, it's just power. Power is power. Now,
Yes,
I need to get this connected to my computer. So I've got this little cord right here. And hopefully this works because we had to reset this right before the episode.
What could go wrong,
what could
Padre?
possibly-
A live demo on this set?
Yeah, nothing, right?
Nothing.
Now here we go. So we're going to go into Arduino. Go ahead and bring this up, Alex. This is the Arduino IDE. Now remember, we need to know what port we're on right now. And the shortcut is, if you go out to the full screen, Alex, there we go. The shortcut is to go to Properties on my computer, if you're running Windows, Device Manager, and then if you open up the COM ports, it will show you where the Arduino is. In this case, it's going to say Arduino Uno on COM5.
Okay.
Okay, so remember that because my Arduino will be on COM5 for the duration of this episode.
And it could be different for other people. And does it?
Correct.
Does it change the COM every other time that you plug it in? Or
no,
so?
but like if the reason why it's 5 is because I've plugged in several Arduinos beforehand, and they're COM3 and COM4. This is COM5. Right. So I'm going to go into my IDE and I'm going to set my COM. So right now it's set for COM8, which doesn't exist.
Nope.
But it used to. There was another Arduino that was COM8.
Back in the day.
Back in the day. I'm going to set that to COM5, and then I'm going to set my board to an Arduino Uno, which actually already is.
Cool.
And that's because it needs to know where it is, and then it needs to know how to talk to it.
Yeah. Where and what?
Where and what. Now, go full size this, Alex. This is what the standard IDE looks like. This is empty. There's nothing in there. But look what I can do. If I go to File, Examples, it brings down this entire list of these examples that are built into the IDE. If I go down, you'll notice there's one under servo, and there's two examples. There's knob and there's sweep.
I'm going to take a guess and say that we have knob, but
We have knob,
I
but
don't know what a sweep would be.
Well, let's start with the sweep. So this is what the code for the sweep looks like. Let me open this up. This is pre-written. I didn't have to write anything.
Well, it was written by Scott Fitzgerald.
Yes, it was. It includes a library called the servo.h. So that's the library that has all the commands, so I can tell the servo what to do. All it's going to do is it has this integer called position.
0.
Sets it to 0, and then this loop goes from 0 all the way up to 180, and then from 180 all the way back down to 0, and it just repeats and repeats and repeats. So once I plug this in, we should see the servo just kind of going back and forth, back and forth. That's the sweep.
Right. Okay, that makes sense.
So what I'm going to do is I need to assign the pin, or I need to know what pin it's attached to. Brian, if go ahead and go back to the screen there. Can you see anything that might possibly tell me what pin the servo is attached to?
Let's see. Void loop.
Like maybe right under setup, maybe.
Right under setup. Oh, attach 9?
Exactly.
Yeah, attaches a servo, pin 9.
Exactly. So always look for the comment codes because these examples are very well commented. So this is telling me that number 9 in my servo.attach sends the data to pin 9. So I have to connect my servo to pin 9. Now I
could change that.
Exactly. I could change it, but and I don't think you can get a shot of this, Alex, but if you go to the overhead, some of these pins have a little tilde next to it.
Yeah, what does that mean?
That means that those outputs can do PWM.
Oh, okay. So yeah, you see 9, 10, 11 do, and
I could
6,
not use
5,
7. I
and
could
3.
not use 8.
Oh, okay.
I mean, you could technically do PWM with the others, but yeah, use one of the PWM pins. So I'm going to take this and I'm going to connect it to 9, which is the pin that I want. And you've heard it. It already kind of, yeah.
Actually,
But
I thought that was the noise of the pin going into this. I was like, that was weird.
Okay, so I'm going to upload. Go back to my screen, Alex. And this is going to compile the sketch. Then it's going to push it up through the COM port. And once it's done, there we go.
I can hear it.
See?
You can't really see it because there's
and I just pulled the pin out. I'm a bad person. Sorry about that.
Making it suffer.
Reset, please. Okay, so I'm going to reset. And now that you can hear it. See, it's going back and forth.
It is, yeah.
So that's the sweep. So right now, this little servo is just going back and forth. It's going from 0 to 180, 180 to 0, 0 to 180, 180 to 0.
And that's the full range of motion for the little servo?
That is the full range, well, for this particular one.
For this one, right.
Yeah. There is a cool trick, and we will do it later on, where you can take the stop out of a servo and it just becomes a continuous operation motor, which...
I would really like to do that. I want to make a Lazy Susan for some of our product reviews, and I'd like to have a Arduino that just spins a product on like a platform.
Well, you need a bigger servo because this is a micro
baby
servo. Not a whole lot of torque.
No.
Also, this servo is about as big as you can run off of the Arduino. In fact, if you look at the lights on the Arduino,
they start to get dim.
Every time like it gets towards the end, they dim because it's pulling a bit too much current.
So what would you do if you wanted a larger servo? Have another power supply?
You would have an independent power supply.
Okay.
Now, here's the fun thing. We just showed you how to do that with a servo, but a speed controller, an electronic speed controller, like the one we have hooked up to this motor, it works exactly the same. It just looks for that positional data, the PWM pulse, to tell it where it should be set. So theoretically, what I can do is I don't need power, because power is going to come from that battery.
Right.
But I can connect this to the exact same pins, ground and signal. So this brown one's going to go to black, and the signal pin's going to go to white.
Right. And then you're getting power from a battery?
I'm getting power from a battery, and so if I plug this in, like so, there we go, let it.
So now you're able to spin that with your...
But see, you can hear it sweeping, so it's going up and then down, up and then down, up and down. So it's doing exactly what the servo did, but the difference here is the ESC is actually interpreting that signal and telling it how fast to throttle up.
Right. It's interpreting it as the throttle. That's cool.
Right. So yeah, I'm using this. I am using an Uno, but I could just as easily have used the little Nano that I used. The only reason why I use this is because I've already got a breadboard. It makes it a little easier to mock this up.
Right.
But let's go one step further, because this shows me one way to spin up a motor with my Arduino, but it's not real useful. It's just going to go up and down, and I don't know if I want that. It would be nice if I could duplicate the functionality of this little rotary encoder.
And that would be under the knob?
And that would be under the knob. Again, I don't have to rewrite this. Alex, if you go ahead and go back over here, I'm going to close this window. And I'm going to open up the other example under the servo heading called knob. Now, just like it sounds, it's going to do the same thing as the sweep program, but the difference is that it's going to take input from a knob, from an analog knob, and turn that into the PWM value that it sends to the ESC or the servo. So let's look at what we need to do here. First, pot pin equals 0. That's the analog pin used to connect to the potentiometer. That's the knob. So I need to hook up the knob
and set it to 0.
To 0, right? To analog pin 0. The other one is my servo attach 9. So it's still connected. The servo is still connected to digital pin 9. That's what's going to give the data out to the ESC.
Okay.
So I need the analog pin from the potentiometer connected to analog 0,
right.
and I need the data pin from the ESC connected to pin 9.
Right. Okay.
So let's do that. Here's how it's going to look. I need to give, if you go to the overhead, I'm going to use this potentiometer right here. Okay. I need to give this power. So there's 3 pins, 3 positions, right? I need one side to be ground. I need one side to be voltage. The middle pin is the one that's going to vary. So that's the one I have to tie into 0.
That's basically your data pin?
That's my data pin, right.
And do you have to make sure this is at 0? Or
no, it doesn't matter.
Okay.
Yeah, we'll reset that later on. So the way that a breadboard works is all the holes across have the same link. So that hole right there is also linked to that one.
Got it.
So I'm going to do that. I'm going to go from there to analog pin 0.
Cool.
So from that to 0, now I need to give this voltage. So I'm going to go from here, and it really doesn't matter. I can do it either way. I'm going to go here to ground, and I'm going to go from here
to
5 volts. Right. I'm going to give it 5 volts. Like, maybe if I can.
You must be very delicate.
Don't touch the sides.
Don't cross the streams.
Butterfingers. Okay, so now what I've got is I've got voltage going into my potentiometer, and I've got that blue wire giving me a value, an analog value back to analog pin 0.
Cool.
Okay, so let's go ahead and upload this
Send
code.
the software, okay.
There we go.
And I'm guessing that the loop, the void loop, is probably just, it keeps checking to see what the value's at?
Exactly. It just keeps checking the value of the analog pin, and then it sets that to the value it's sending out to the ESC.
Okay.
So let's go ahead and plug this in. Okay, and let it. There we go. See? So now this knob, as I turn this, it's going to spin up to full speed.
Full speed,
Back
half
down.
speed, 0. Oh, that's cool. Nice. So yeah, now you have control over it.
Exactly. And now I'm doing, not only am I doing what this did, but I can actually do it with way more precision.
Right.
I could open up a serial console and I could reprogram this so that it sends me exactly what is the value that it's sending.
Right.
The other nice thing about this is you can find out where is your ESC set. Is it set to start as soon as that value gets to 1,000? Or does it wait until it gets to 1,200? And then it will tell you whether or not you have to recalibrate your ESC.
Okay. Yeah, that's handy to know.
In fact, folks, let's do homework. If you do have an Arduino, if you have an ESC lying around, you want to play with this, I want to see your code examples. Go ahead and take this. Give yourself a serial monitor. In fact, there is one more thing that you can do. You could avoid the knob altogether. You could use the keyboard or the console to enter in a value. You could say like 40% thrust and hit execute. It would go to 40%. Or you could say like use a plus and a minus to increase and decrease.
Yeah.
You could do this on your phone.
Oh, if you had the Bluetooth
If you have the
module?
Bluetooth module. So go crazy. If you've got an Arduino, if you've got some Arduino parts, let's see what you can do with PWM.
Nice. I
Sound
like
fun?
it. Yeah, that sounds very fun.
Yeah. Well, good. I'm glad you like it because, believe it or not, we're going to use the lessons we just used here to answer another question that someone has about a project.
Well, that's why it's an Arduino Wonderland.
That's why it's an Arduino Wonderland. But before we get to that, you know what I want to do, Brian?
What's that?
I want to pay some bills.
Yeah, we need to pay those bills.
Yeah, but I'm going to pay it in a nice way because I get to talk about a company that I actually really, really like. It's a company that's been with us for a very long time, a company that's provided us with a lot of the tools that we use here on the show, and it's iFixit. Now, iFixit is the go-to place because not only do they have the best tools and the best parts, really the toolkits that we love, but they also have the manuals. I cannot stress enough what it's like to have an instant reference to pretty much every device I may ever want to open, I may want to repair, or I may want to hack.
Yes,
Yeah,
definitely.
yeah. From the Xbox and its red ring of death to something like a doorknob to sewing, iFixit is really good about making sure that you have the information you need to make the most informed decisions as a hacking geek. Now, right now, iFixit is offering the brand new, all awesome brand new iFixit toolkit. This is a fantastic piece of gear that, well, it's reimagined. They took what we like the most from the old iFixit kit, all the bits and all the drivers and all the specialty parts. They made it smaller, and then they put everything in a magnetic tray to reduce the risk of you losing all your individual bits. This is the de facto standard for the geek. If you love to disassemble things, if you like to fix gear on your own, that's the kit that you need. It includes a 64-bit driver kit, which replaced the former 54-bit driver kit. It's got that more durable case. It's got magnets. That 64-bit kit, it's held held to the tool roll using magnets. That's actually kind of cool. If you pull hard enough, you'll pull it right off the roll, and then it snaps back into place when you're done with all your work. Now, more bits means fewer repair roadblocks, and a newly redesigned swivel top precision driver means you can get into those hard-to-reach places. They also give you a flex extension for hard-to-reach screws. They've got precision ESD-safe tweezers, including a pair of reverse tweezers. You've got a wider variety of plastic opening tools and spudgers and picks to safely work on tablets and smartphones without marring the surface. It's got a suction cup for display assembly removal, a metal spudger, and iFixit's own rubber-handed Jimmy Pry tool to help you get into those really stubborn enclosures. Of course, they include an ESD safety strap to make sure that you don't destroy the equipment that you're trying to fix with a static shock. Now, the best part is that this is all backed by iFixit's lifetime warranty. Buy it because it's awesome, or don't, and you'll still get free access to all the repair resources on iFixit.com. That's what they want to do. They want to encourage the community of makers and builders. Folks, grab yourself an all-new ProTech toolkit and get going on your next fix, hack, or build. Just head over to iFixit.com/twit. That's iFixit.com/twit, and use the code KNOWHOW at checkout to save $5 on your purchase of $10 or more. Folks, we love iFixit, and we thank them for their support of Know-How. Hey, Brian, you want to get back to it?
Yes, please.
So we've been playing with an Arduino. We've been showing you what you can do with it. We've been showing you that
PWM.
you can use it to play with PWM, and luckily we had a great project suggestion from a member of our know-it-alls in the Google Plus group. What do we got?
All right, this one comes from Burnett, and he asks, "Hi everyone, I have a project that I hope could be very simple. I would like to automate a chicken coop door so that it would raise and lower at set times during the day, open in the morning, close in the evening. I feel this could be done with an Arduino and a motor, but I am unsure how to make one motor rotate both directions as needed. Any advice?" I like this question.
This is cool, and we live in the chicken capital of California.
There's 2 chickens that live in my backyard.
Boom. How about
and
that?
It's funny. They let themselves out in the morning. They put themselves to bed, but you have to go out there and shut the gate.
Well, what if we had a way not to shut the gate?
Automate it?
Automatic, with the Arduino thing.
Yeah. How would you do it?
Okay, so first of all, there's a few different ways to do this. You could just get a motor that has 2 stops. So it has a switch when the gate hits one area, and then another switch when the gate hits another area, so it knows that's when you cut off the motor.
Yeah.
I would actually go for a slightly more elegant solution. I would use a stepper motor. A stepper motor is like a servo motor in that I can determine the exact position of that motor. So I can actually count how many times it's rotated. So I know how many times it needs to go. I can tell it to go that many times, and then I can tell it to rotate back.
Oh, okay.
So it's just like addressing the servo. The only difference is stepper motors have a whole heck of a lot more torque.
Okay, and that's probably something you would need to either open or close a gate sort of thing. Yeah.
Right. Now, I'm not telling you which way to do it. You can go with the standard, like a 2-phase motor connected to some gears and then some start-stop switches. That works just fine, and you can do that with an Arduino as well. But that's not the hard part of the project. The part of the project is how to make it automated. Because it's not like he wants to turn on the Arduino and make it open or close the gate. He wants the Arduino to do it automatically.
Certain times. So it would have to be powered, and it would have to have a clock that would tell it when to close and open.
Precisely. We're going to need a clock. Now, every Arduino, by its nature, in fact, every piece of equipment by its nature, will have a clock. And the way that works is you take a piece of crystal, quartz crystal, and you squeeze it. And when you squeeze it, it's going to vibrate 14,000 times a second.
And then you can use that vibration to figure out
you divide
how much
it,
time has passed.
Yeah, exactly. Divide it by how many times it's vibrated, and that gives you how many seconds. Yeah. The issue with that, though, is it's not all that accurate because the vibrations can vary with heat and pressure. So hot day, it's going to run faster. Cold day, it's going to run slower. Before you know it, the time that you set according to that is drifted way the heck off.
So what if you use like a light sensor or something like that?
You could use a light sensor. Yeah, you absolutely could use a light sensor, but you have the same problem. Now, okay, well, if the sensor gets clogged up.
Right, or it's really cloudy one day and it just never lets the chickens out.
Precisely. Better is to use one of these. This is a RTC, a real-time clock, and just like the name might suggest, it's an actual clock. There's a clock on here with a battery so that even if the Arduino shuts off, it's going to keep time.
Nice.
This clock will always run, and it's always going to run at a predictable rate, which means it's going to give me the actual time.
That
so
sounds perfect.
I can program my Arduino to say open the gate at 6 a.m. and close the gate at 6 p.m.
Nice. Yeah, it looks like just a little watch battery.
That's all it is. And actually, it's here. You can see it in the overhead. And actually, I think, Alex, we've got a link here to an Amazon. There are so many of these. You don't have to use this link. This is one of the cheaper ones. It was 37 cents. And
wow.
Yeah, $2.49 shipping. These are not expensive devices, but we need to know how to use them. And you know what? Surprisingly, we actually have an expert who can tell us exactly how to use it.
Well, it's not me. Is it Alex?
No. It's a man by the name of Smitty.
That little metal canister right there, that is a 16 megahertz clock, and it's 16 megahertz-ish. It's not very precise.
It's quartz, right?
It's a quartz crystal.
And they just figured out that when you compress it, it's going to vibrate a certain number of times per second, and that's what gives you your timing.
Exactly. But it's not very precise.
Right.
And so if you rely on that to count the time, it'll be slow or fast, or it'll change over time. They're not very well heat compensated. For a microprocessor that's just doing stuff, it doesn't really matter. But if you care about the timing, like in your case for the quadcopters, I need to be able to spin those fans at a very precise speed, right? And I need to be able to set that servo at a very precise value. Okay, in that case, a real-time clock really matters. In our case, we're trying to tell the time, and I want to know what time it is, and I don't want my clock to drift over time, and so I want a very precise clock. The real-time clock uses a protocol called I2C, or IIC. I have no idea what it stands for.
I used to know that.
It's a proper noun now. It's I2C. It is a serial bus. You see over here where it says SCL and SDA. That stands for system clock, or I'm sorry, serial clock and serial data. Those are where the actual data is between the real-time clock and the Arduino. And then VCC is your power source, and ground is your negative power source. So those 4 pins are all you need to populate this real-time clock to be able to get the data into and out of it. And then we have similar pins over on the other side. This particular real-time clock module just has them on both sides for convenience. What we are going to do, there are 2 other pins on top here. The 32K is a very precise 32 kilohertz output that you can use to drive other counters and whatever else if you need a very precise clock. We're not going to be using that. And then the SQW, I'm not entirely sure what that is. I think that stands for square wave. I think that's a pulse per second.
Yes.
Again, we're not going to be using that. All we care about right now are the power and the serial clock and serial data pins. We're going to be using the I2C bus out of this. On the Arduino Uno, I2C is on pins A5 and A4. If you look at the pins on the real-time clock there, I can actually put the real-time clock into the Arduino directly like that.
And we're not using the 32K, and we're not using the square wave.
We're not using the 32K, we're not using the square wave, but if you put them in like that, that puts the serial clock and serial data in the correct pins, and then I just need to configure the Arduino to give a positive voltage on the VCC and a negative voltage.
We do have to say, it's not going to be as simple as turning on your IDE because you've added a component. The RTC is something very specific that not every Arduino developer is going to be using, so we need a library.
A library.
And everyone who's watched Coding 101 knows what libraries are. Libraries are basically just code that someone else wrote that you can import and use.
Correct. So we're going to be loading, we're actually not going to be doing it on show because it's dependent on what operating system you're running and where you get the libraries and all that. But it is a very simple process. There are lots of tutorials on YouTube and...
Yeah, you learn how to do it once and then that's it.
And that's it.
That's it.
So in this particular case, you could, in theory, write your own code that talks I2C to the real-time clock and talks the protocol that the real-time clock is expecting and calls the right functions and pulls out the right data and all that.
You could.
You could, Or you could just import the library that the people who made this have already written, and then you just call rtc.get the loop. Again, remember from last week that loop just gets called over and over and over again. And so we need to do whatever we're going to do in this time. So TM element is a data type that is defined in time.h. And what this is an object that has a bunch of different time elements. So you'll see like time.hour, time.minute, time.second. So if you load a time into the TM variable, and we're doing that with the RTC read here, then we can use that to get out all of the internal elements of that time. So it's a grouping of data that all serves the same purpose that we're going to try and get and pull different bits and pieces out of it.
Okay.
So let's go back to the code. So RTC, remember when I told you about we have a library that we use for reading things? That is right there. This line is how we read something from the real-time clock. That is a heck of a lot easier than writing I2C protocol code, right? Somebody else did all the complexity for me. All I have to do is rtc.read, give it a time elements object, and it will populate that time elements object with the current value from the RTC.
Fantastic.
So our program reads from the RTC and outputs to the serial port.
Right.
So now we need to hook up to the serial port and see if we see anything. Luckily, Arduino helps us with that as well. Go to Tools and Serial Monitor. All right, let's bring up the serial monitor. Hey, look at that.
And this is just the information that is pushing back over the serial bus.
That's correct.
So hello world, that was in our the initial statement. So that's the system. That's
setup.
The setup. That's the setup. And then right below it, we're now seeing the output from the loop.
Correct.
Fantastic.
That's it.
And that's it. So this has allowed us to take input from the RTC using the library, get the right data, and then push out just the pieces that we want. So that's not actually outputting everything that's coming out of the RCT. It's not just a dump.
Correct.
It's selecting hours, minutes, and seconds.
Okay. That's right.
That was from an episode of Coding 101 way back.
I remember,
we're going to do it again. This little device, this little inexpensive device, has so much promise for things that you want to do. You had an idea for making some sleep lighting.
Sleep lighting that slowly increases as it gets closer to the time that you would like to wake up, or turn off at certain times, things like that.
Go red. Yeah,
Go
red.
Red
Helps you set the circadian rhythms or something
and
like
it just looks cool.
It just looks cool. It really does. It really does. Yeah, so we will be playing with RTCs. It's using the I2C protocol, which is nice because we're going to be doing a special Arduino episode in the near future on groove devices. You may remember we covered them as a banter item not too long ago. It's a way to daisy chain a whole lot of devices to a single bus.
Get your groove on.
Get your groove on. So we've got everything from the real-time clock to rotary encoders, which is a nice way of saying a knob,
right?
To things like touch sensors, screens, temperature, humidity, sound sensors. Those can all be put into a chain of I2C devices, and it really expands what you do with your Arduino. It's no longer you just pushing stuff out. You can now have your Arduino be smart. It can sense the world around it.
Data collect. I like it. That's cool.
Yeah. Everything from what time it is to is there noise, because if there's noise, I should turn the lights on or something like that. Although, no, not going there. All right, folks. When we come back, we're taking the Arduino to a whole new level. I mean, when we think of Arduinos, we think of these Nanos. We think of, the Arduino Uno. We think of a lot of Atmel-powered chipsets. But we're actually going to play with something else that goes by the name of Arduino, but actually runs an Intel processor. This is the Arduino 101 using Intel's Curie chip, which has a bunch of stuff that you're going to love. So stay tapped for that. But before we get to it, I do want to thank another sponsor. I want to thank the sponsor of this episode of Know How. Now, Brian, here's the fun thing. If you are a maker, if you're a doer, you are at some point going to create something for consumption on the web. That's just how it works, right?
Yeah, totally.
Yeah. Now, if you want to enable certain features, let's say you want to add chat. Let's say you want to have a Minecraft server for some reason.
That's what I was going to say, is that most of my motivation is gaming.
It's gaming, yeah. You want to add a gaming server. You could do it the old way. And the old way would be for you to buy space to store a server in, to actually buy the server, to make sure that all the software is up to date, get a contract with an ISP so you have the bandwidth. Oh, and by the way, monitor that to make sure you're not going over your monthly caps, and make sure that the experience is good enough for everyone who's connecting.
And if you wanted to add certain features or expand your system, it was a real pain.
Yeah, not just a real pain, but they're going to charge you a lot. A lot of these companies love to nickel and dime you with every little surcharge they can think of for every little extra bit of bandwidth that you want or every little extra bit of availability.
I feel like there's a better way, Bob.
There is a better way. And guess what? It's called DigitalOcean. Now, DigitalOcean is not just a good way for you to get your service, your app, your latest project out on the internet. It is the best way. DigitalOcean is used by over 600,000 developers, including Twit's Randall Swartz, Aaron Newcomb, and of course, myself. What makes it so special is the fact that it uses droplets. These are containers that you can use via a streamlined control panel or a simple API. They're flexible. You can spin them up and down as you need. You can build it to scale. In other words, you don't have to have hardware that's just sitting around doing nothing. You only spin up these droplets when they're needed. It's one of the things that I love about DigitalOcean, and I tell you, that is the future of services on the internet. Now, it's not only that it's really flexible, it's also that you can set it up the way you want to. No more being bound by the rules of the provider. With DigitalOcean, you get to choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. They also have pre-configured one-click installs for Drupal, Docker, and Node.js, among others. You can get up and running quickly, or you can build the exact infrastructure that you want and you need, with root access to servers running 100% SSDs in a state-of-the-art data center that's co-located around the world. DigitalOcean is highly scalable to meet the demands of a rapidly growing application or business. You could have it open for just a few minutes, a few seconds even, to entice people to your service. Maybe test it out, see how it's going to handle real-world traffic, and then open the taps with a simple tap of an interface button and be live global. That's one of the things that's amazing about DigitalOcean, the ease and the speed with which you can take a project from very small to very, very big. Now, one of the things I really like about DigitalOcean is the fact that the community, the people who actually use it, are incredibly active. They've got a large and detailed set of tutorials on the ways that you can use your droplet, and they'll help you. If you ever run into a problem, there are people who are so passionate about DigitalOcean, about the droplets, about what the service has done for their creativity, that they're willing to help out newcomers. And for me, that just screams win. It's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. Really, I can't think of any reason why you wouldn't want to use DigitalOcean, except maybe cost. And let me get rid of that reason right now, because DigitalOcean has an incredibly affordable and straightforward pricing with servers starting at just $5 a month. There's also hourly pricing available starting at less than a penny per hour. But we're going to make it so that you can get started today and deploy an SSD cloud server for free. Just visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code KNOWHOW for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. Again, that's DigitalOcean.com, DigitalOcean.com. And once you sign up, enter the code KNOWHOW, KNOWHOW, in the billing section to get your $10 credit for free. And we thank DigitalOcean for their support of Know-How. Hey, Brian.
Yeah?
You want to do this?
Yeah, I do.
I do. So this is the Arduino 101. It looks just like an Arduino. In fact, let me go ahead and pull out our little knob job here, and you'll notice that I could pull this out of the mount, and I can press this one in. They're compatible, and they're designed that way because these are both Arduinos. The only difference is that this is using an Intel Curie chipset rather than the Atmega chipset.
Okay, yeah, because the GPIO ports look identical. All the other
pins are the same.
There.
And that's by nature, because they want people to understand that you can take the same kind of code, not exactly the same code, but the same kind of code, and you can port it to a device that is infinitely more capable.
Do you have to use a different IDE then?
No, you still use Sketch. You still use the Arduino. In fact, we're going to show you how we use the Arduino Ide. It just means some of the libraries that access like Atmel specific pieces won't work quite right. Like the FastLed library that we love so much, that's not going to work out of the box on a Curie. I am modifying it so that it will. I just have to take out a couple of references and point to the Intel libraries instead of the Atmel libraries.
Okay.
But yeah, more or less it's the same.
So why would you use this Intel one over
I'm glad you asked, Brian, because in this, it's not just the same kind of pins. You have Bluetooth LE, So low energy Bluetooth. So you can use this as a beacon. Integrated. That's what this antenna does. Oh. And there is a 6-axis IMU. It's a gyroscope. So it allows me to use this like a flight controller. Like this will be positionally aware. It knows where it is, and it can wirelessly communicate to other devices without me ever having to plug anything into it.
I like that idea already.
Yeah. So let me show you why you're going to want to try this at least. Because if you've been doing any sort of Arduino development, this is something that definitely needs to be in your kit. Now remember, the Curry chipset itself it's tiny. All of this is just support gear. So if you were going to create something for the Intel Curry, I can get something that's even smaller than this Nano, but it could be Curry based instead of Atmel based.
Huh. And is there a big price difference between the two, or depends?
Yes. I will say yes because, well, okay, no. No, but yes. No, in the sense that if you buy a genuine Arduino,
same price. It's
going to be about the same price.
Okay.
So these will go $20 to $30. If you buy this, it's going to be $30.
Okay. But
there are no clones of this yet.
So you can't go on eBay and buy like a bunch of cheap
You
ones.
might be able, actually by now you might be able to because it's been out a while. Eventually it will get there, but right now it's mostly authentic stock that you're going to buy, so it's going to be more expensive.
Okay, so basically if you're looking at genuine parts, it is the same price.
Yes, and if you want to be supportive of the microelectronics embedded community, buy
genuine. And if you're concerned about doing a project that might fail, you know, if it's a project too important to fail, buy a genuine one.
Yeah, there we go. All right, so let's go ahead and show you how this is going to work. Again, I'm not going to write any of this code. I am going to modify a tiny bit of it. Yeah. But this is something that they can download straight off of the Arduino site. What we want to do is we want to enable the IMU functions. We want to be able to use this to find out, you know, what's happening with the board in its positional data.
Yeah.
And we need a way to see that because it's one thing for the Arduino to know what's going on, but I need to know what the Arduino is experiencing. Like if I'm going to use this as a sensor, I need a way to see what the sensor sees.
Exactly, yep.
Okay. Yep. So I'm going to actually need two parts for this. The first part is I'm going to need to set up the Arduino Ide with two libraries. One is the Curie IMU, that's a library, and the other one is called Madwick. And Madwick is, yeah, it sounds a little crazy, but it's important. Okay. So let's go ahead and open this up. Actually, let me show you something first, because this is kind of important. If I connect this, let's see, let Windows 8 do its thing. It's actually not going to be able to find a driver unless I reinstall it.
So it's not going to pop up on COM5?
There we go, see? Notice that. Go ahead and zoom in on that, Alex. Arduino 101, this is what Windows does when it goes, I don't know what to do with this.
Oh, okay. So what do you have to do?
What I have to do, and this is not so intuitive, so please pay attention so you don't spend half an hour like I did trying to figure out what I did wrong. Yeah. You're going to go into the Arduino Ide. There we go. Start it up. And I need to go into the core menu. So I'm going to Tools and see where it says Board.
Yeah.
I'm going to manage my board.
Oh, okay, because it's not on the list by default?
Correct. And then what I need to do is I need to scroll down to Intel Curry boards by Intel. See, right there.
Okay.
See that package?
Do they make only one?
Yep. Click that. Click Install.
Okay.
And let it do its thing.
And it will find which port it's on anyway?
Well, I mean, after I get this installed, it's going to act like a regular Arduino. I just need to be able to tell both the integrated developer environment and the computer and Windows that it's going to be connecting to a Curry rather than to an Atmel. Okay, so now that it's installed, what it's done is it's not just added the core for the IDE, but it's also added the drivers. So if I plug this back in.
And that's for the, not the EMU, the IMU?
For the EMU.
For the EMU.
For the EMU. No, actually, so what I can do is I can go to the computer. I'm going to go to Properties. I'll go back to Device Manager. And notice how it's now there. So Arduino 101 serial monitor COM9.
Nice. So would you be able to see this on Bluetooth now at this point, or?
Well, yeah, I'd have to set that up.
Okay.
But yes, yeah, you could. Okay. Exactly. But I'm using wired, and you'll see why I'm going to use wired in just a bit. So that gives me my connection. Now I have the board ready to talk to the computer, and the IDE knows, oh, okay, I have this new thing. In fact, if you go back to the Arduino sketch, here where I can choose what kind of board, notice how at the bottom I now have an Arduino Genuino 101. And I also know what COM port was I connected to? COM port 9. So now I've just told Arduino that you've got a new type of board. It's connected to port 9, and install the drivers so that Windows will be able to speak to it.
Cool.
Okay.
So now we can start uploading software to it?
Now we can start uploading software to it, but not really. Okay. So what we're going to do is we're going to need those two libraries I talked about. I need the IMU library, and I need the Madwick library.
Madwick, right.
Exactly. So I'm going to go to Tools. Oh, sorry, to Libraries. I'm going to put Include Library, and then I'm going to go to Manage Libraries. And this is a very easy interface. So I'm going to go ahead and download the list.
It's updating the list.
There we go. I'm going to go ahead and type in Curie IMU. There you go. And you'll notice this one's already installed. And the reason why it installed is because when I installed the library, the driver for the Curie,
it just automatically grabbed
it automatically grabbed that one. The other one is the Madwick. So if I type in MAD, notice how this one's not installed.
By Arduino.
So if I click that, I install it. This is the library that's going to allow me to access the IMU, the accelerometer and the gyroscope.
Nice. Yeah, it's the algorithm to get the orientation.
Exactly. So now that's downloaded and that's ready to go. What I'm going to do is I'm not going to do anything special here. I'm going to copy and paste code directly from the Arduino site. Alex, if you go back to my screen, this is the Arduino Genuino screen. I'm just going to copy and paste this entire block. What this is going to do is it's going to upload firmware to this new Arduino 101 to tell it to push out its location values to the serial port.
So then you can see what information it's logging.
Precisely. So here we go. I have to make sure you have this flat, because just like when we've got a flight controller, we have to make sure that it's level before we upload.
So don't be shaking it around.
Don't be shaking it around. So let's go ahead and save my sketch. It's going to compile it, and then it's going to start uploading it. I'm going to get a little bit of warning, and after it's done compiling, there we go. Now we're starting the upload. There we go. So it's uploaded, and in 5 seconds, I'm going to hold this for 5 seconds so that it stays level. Good. Okay. So now that firmware is uploaded into this Arduino, and this Arduino is starting to send data back down the serial cable, the USB cable, that my computer needs to somehow interpret, because this is doing its job. It's sending out its position.
But what software are you using to display that or receive it?
Exactly. And that's where we're going to get a little funky, because we're going to be using processing. This is
the name of the program?
That's
Okay.
Yeah. So this is what it looks like. This is a great way to write a back end or a front end to your Arduino project, because this will take the signals that I'm getting down the wired cable or over Bluetooth if I want to go wirelessly, and it will allow me to display it in any particular way.
Okay.
I don't have to do any programming, because I'm just going to take the processing code from the Arduino page. Here we go. Copy and paste. Remember, this is how you always start. Copy and paste someone else's code and then improve it.
Right.
Now, there is one thing that I do have to do, because you'll notice right here, if you can zoom in on that, Alex.
My port equals new serial?
I have to tell it where my serial port is.
Right.
Now, I could count on it trying to find out from Arduino where that serial port is, but I would prefer not to do that. I would prefer to hard code it. So what I'm going to do is I'm going to comment out this line, and I'm going to uncomment this line, and I'm going to tell it right here what COM port I am. And
it was COM 9, right?
COM port 9, exactly. So let me shut down the Arduino so I don't get any COM port, COM port 9. I don't get any COM port conflicts. And now if we start the sketch, allow access. It should pop up a little window as soon as it's done compiling.
So this is telling programming what.
There we go. See down at the bottom here? Alex, down below the bug, down there. You'll see that those values are starting to come in, right?
Okay, okay.
And if I open this up, go ahead and go back out.
And it's even giving you the 3D render.
Exactly.
That's awesome.
So this is the positional data that I'm getting from this Arduino board. So that's the integrated, that's the IMU that's already on the board.
It looks pretty accurate. Do you have to do any calibration, or just hold it still when it first
I just hold it still. So I
Okay.
wasn't quite level, so it's a little floppy. But see, look at that. It's actually really, really accurate. It even gets the roll.
That is cool. Oh man, there's so many projects I want to do with this with.
So what I was thinking is, this is all, see, that's the positional data. So if I wanted to, I could open up the serial console on the Arduino and I could just push those numbers out, like we did for when we were doing the LED debugging.
Right.
But that doesn't tell us a lot. I mean, we can interpret the numbers, but having a graphic interface that actually shows you what it's doing, much better.
Oh yeah, absolutely.
Yeah. I've got a couple of ideas for this. I want to make a black box.
That's exactly
This was one of your
what I was
ideas.
thinking. Yeah, I wanted a black box for my motorcycle that tells me acceleration, lean angle, GPS.
And this can do all of that. And it can do it wirelessly. So we can set this up so it would be in a 3D printed box, like mounted underneath your seat.
Yeah.
It would connect to your phone, and we'll write a custom app for your phone using processing that will collect that data.
That is so cool.
Right?
I want to do that right now.
And what I really want to do is I want to be able to overlay that with like a video that the phone is capturing. So
Yeah.
it could show you, and as you start to lean, you'll see it on the camera, and you'll actually start to see like G-forces increase. How cool would that be?
That would be awesome.
Yeah.
I mean,
This-
it doesn't have to be just motorcycle. I mean, that could be quadcopter, that could be your car, that could be
Or
anything.
when I'm walking, I build
walking,
up
yeah.
some G-forces.
I bet, yeah.
My lean is pretty crazy, man. I just gotta tell you.
I can only imagine. We better start data logging it just so we
Exactly.
can have it on record.
But what I like about this is we're now taking the Arduino from something that was fun to something where that could be a product. I mean, I've seen products that are not as useful sell. So why
Right, and this is something that you're doing yourself that you can customize to your own, well, your own ideas. Yeah, I like that.
Exactly. Well, folks, we know that this has been a lot of information, everything from the two projects, the semi-projects, to this. We're going to make sure you get links to everything and links to the code that you can copy and use on your own. And remember, most of those sketches are going to be found in your Arduino IDE, so go ahead and try it out. You can't break it. Upload, re-upload, break the code,
You
and
just
then
have to reset it.
re-upload. Yeah, exactly. That's how you're going to learn, and that's how you're going to be part of the Arduino Wonderland. Now, Brian, at the end of the show, we always say the same thing, which is if they want to find all of our episodes and all of our show notes, they got to go where?
twit.tv/KH. We've got all our past episodes linked there, and you can subscribe and you can download the episode, which is probably going to be handy if you need to go back and watch something over. But that's not the only place that we are on the interwebs.
No, you'll find us on our Know How group. Just go to Google+, look for Know How. It's a great place for you to gather almost 10,000 members, know-it-alls, who will do everything from posting potential projects and asking for your input, or they'll give you a challenge, a question that they have that maybe you can answer. If you have any inkling of being a DIY or a maker, there's no reason why you can't be a part of that group.
That's right. I mean, that's how we came up with the idea for this episode,
Yeah.
with people asking Arduino questions.
Boom, how about that? Of course, that's not the only socials you'll find us at. We're also on the tweeters. You'll find me at twitter.com/PadreSJ.
And I am at cranky_hippo. That's definitely the best way to find out what we're doing when we're not on the show or what's coming up on a show. But we wouldn't be able to do this show without
Steven.
our esteemed colleague.
Yeah. ANELF3. It's at ANELF3 on Twitter. Drop Steve a line, because Steve could really use it. He's a good guy.
He's a good guy. He's been here for years.
Excuse me, Padre.
Yeah.
It's pronounced Alex.
It's
So
it's
close.
the French pronunciation.
Right.
See?
That's it.
Steven,
That's what always
Alex.
throws me out.
Yeah. Until next time, I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And now that you know how,
Go into a Wonderland. I was like, there's got to be something there.